Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology, Hyderabad. I welcome you all with another lecture on stream processing and analytics. Today's my topic is introducing Apache Spark. So in the previous video, we have discussed about distributing stream processing. So in this video, we are going to learn about Apache Spark. So here, before going into the topic, we are looking into overview of today's presentation. Okay, I have divided my overview in three parts. The first one is the first wave and the second wave version, that is SQL version, and the third one is a unified engine, which is nothing but Apache Spark. So we'll go deep with one by one in a coming slides. So as a part of our first slide, okay, I'll deal with the functional API. So what it is actually and how it is related with APIs, we'll look into it. So in the world of big data, handling and processing large volumes of data is always been a challenging. So here in today's world, everything is digitalized, right? So that is the reason data is generating on a daily basis with a huge volume. So handling that kind of data is very challenging. Data has grown, so have the difficulties in managing it. So as the data grows, the difficulty level also increases, right? So complexity also increases to handle that particular generated data. So here Spark. So in the distributed stream processing, Spark is one of the framework or technology we can say. It will offer faster and more efficient processing and transform how we handle the big data. Okay, here Apache Spark is one of the technology we can say is offering faster and more efficient distributed data processing and transform how we have handled data in a previous versions, and now how it is helping us to handle that kind of huge data and managing it to preferred choices over Hadoop MapReduce for many organizations. In olden days, organizations used to use Hadoop MapReduce functions for handling big data. Now Spark is also available now. In these days, it is more faster than Hadoop MapReduce. How it is differentiate from Hadoop MapReduce, we'll learn one by one. So as a first wave, Spark has developed as functional API. So in olden days, as a first version, it has developed with application programming interface. In its early days, Spark was driven by the use of memory and expressive functional APIs. Okay, as a first version, it has used both memory as its storage and functional APIs connecting with other applications. So the Spark memory model uses RAM. Okay, to store the data, it used RAM. So if we store data in RAM, it is easy for us to retrieve the data back again, and it is easy for us to store the data as well. So that kind of feature Spark has given for faster big data analysis to cache data as it is processed, resulting in up to 100 times faster than Hadoop MapReduce for batch workloads. So that is the reason we can call it as 100% faster than Hadoop MapReduce. As you can see how it has connected functional APIs between Spark components and one applications, we can see in this diagram. So here in the left side, you can see the applications which was developed by using some programming languages with one IDE environment, environment using some environments. So here in the middle, functional API, Spark has used as functional API to connect with the Spark driver. Okay, Spark driver. It has some schedulers and distributed environment which can use for us to analyze the tasks. So now we'll move to the next slide. In its core abstraction, it has used resilient distributed data sets, RDDs. We can say resilient distributed data set brought a rich functional programming model through distributed computing on a cluster. So as I have told you in the previous slides, previous lectures, Spark works in a distributed computing manner, which means that one central system works as a master and which can handle multiple other systems in a distributed processing. So the usage of this distributed processing is nothing but every task performs parallelly, which can reduce the computing time with respect to the data. So everything is monitored by this master system, we can say, and overall it is called as one cluster. Okay, multiple cluster machines will work to handle huge big data technologies. Okay, it introduced the concepts of transformations and actions. Okay, on data we can perform some transformations and actions based on the scenarios or based on the situations. Okay, these transformation functions are used for us to calculate and manipulate the data, offered a more expressive programming model than the map and reduce stages. So with respect to map and reduce, transformations and actions perform very well and very with a faster pace. In that model, many available transformations like map, flat map, join and filter express the lazy conversion of the data from one internal representation to another. Here transformations, here we have multiple transformations. We can say map is one transformation, flat map is one transformation, join and filter. Okay, all these transformation functions are available for manipulating the data in with respect to some conditions, with respect to some map reduce operations. So here the word lazy conversation or lazy conversion means until we call the function transformation function, it is not going to be executed, which can help us to store, which can help us to store the excess amount of data instead of storing all the data. Okay, so lazy evaluations are, those are called as until we can call the actions or transformation functions. So it can use to reduce the storage of any particular storage. So here you can see that how RDDs work with, and they can providing some transformations and actions. So here we can say parent RDD and number of RDDs work together in a cluster systems, and those RDDs we can apply transformation functions like map, filter and all. And here parallel to transformation function, there are some actions like collect and count. We can apply on those kind of data or any big data related storages. Okay, so that we can get the result in a the main core abstraction of Apache Spark is nothing but RDDs, we can say. Now let's move on to the second part, the second game changer. Okay, after it has evolved as a first wave as a API, as a second version of Spark, it has developed as a data frame or Spark SQL. As you know that SQL is nothing but structured query language, right? It is used to create a databases, tables and all. Okay, so as a second game changer in the history of Spark, project was introduced as a Spark SQL and data frames. Okay, data frame is nothing but it is a combination of rows and columns. In data frames we have rows and columns. Okay, so data we can store in a table manner, which is nothing but a data frame, and SQL is structured query language. We can create the table, we can retrieve, we can update and we can do multiple operations on this kind of query languages. From a high level perspective, Spark SQL adds SQL support to any dataset that has a schema. So in the same manner how we can query tables in a SQL structured query language, in the same manner with respect to Spark also we can apply those queries to the any datasets. If the dataset is in schema, schema is nothing but it has some tabular format or some blueprint. Okay, so if the data is presented in a particular file format, we can apply SQL queries which is related to or similar to SQL database systems. So here it makes it possible to query a comma separated values. Okay, one of the file format we can find to store the data sets are CSV. Okay, CSV is nothing but comma separated values, and the second file format is Parquet file. Okay, this is now a demanding file format which is in demand now to store the big data storages, and or JSON data sets. JSON is nothing but as a third file format we can say JSON, JavaScript object notation. So all these file formats, if we store the data in these file formats, we can query similar to SQL databases. In the same way we used to query a SQL database. So we can apply joins, we can apply all the other SQL functions. From a performance point of view, Spark SQL brought a query optimizer and physical execution engine to Spark, making it faster while using a fewer resources. Okay, with respect to Spark, it will provide query optimizer so that we can less the number of queries we can reduce, and physical execution of the engine, as here Spark works as a execution engine in the middle of data source and data sink. Okay, in a traditional method we can call it as a input, and here process, and as a output, right? But here when it comes to stream processing, the terminology has changed. So in the input place we can take data source, and in the output place we can take data sink. So here Spark works as a execution engine, here execution engine, which can perform on some data sources, and we can get the outputs that are stored on data sinks. So in the same manner, Spark works as a traditional methodology with respect to data. Now we'll see how to create the data frames in Spark. So first of all, as a data generated, that data has to be stored on these multiple file formats. Why? Because storing the data in a best quality also plays a key role, right? So to get the proper insights, we have to store the data in a proper manner so that there is easy for us to query that particular data set. So here if I store my data, let us take a table as an example. If I take here one table and I store my values according to rows and columns similar to data frames. So here name S1, S2, S3 let us take, and values are 10, 20, 30. So it is easy for me based on this rows and column wise retrieval of that data, and easy for developers or any data scientists to get the particular data based on the data frames. So first of all, storing data on a proper format plays a key role. So after storing the data on these particular file formats, then that data is ingested into the Spark SQL. So data is converted as Spark SQL databases, which are nothing but number of rows and columns. Okay, here you can see in the picture data frame, that data file formats are converted as number of rows and columns, which are useful for us to retrieve, and we can store the data easily based on the table. Now as a third part, we are going to learn about Apache Spark. What it is, what the Apache Spark, and how it is useful in big data processing. So we can say Apache Spark is a unified engine. The word meaning unified is nothing but everything is under one. Uni is nothing but one. Okay, everything is available in one feature. Okay, so Apache Spark is a unified engine designed for large scale distributed data processing on premises, in data centers, or in the cloud. Okay, it is works as a unified engine, which means that it will we can connect Apache Spark with all the other devices or all other technologies, so that it can helpful for each and every technology. Spark provides in-memory storage for intermediate computations, making it much faster than Hadoop MapReduce. As I have told you in the previous slide, it uses in-memory storage. In-memory is nothing but it will store the data set or a database in RAM, which is easy for us to store and easy for us to retrieve the stored data. So because of its in-memory storage, it is faster than Hadoop MapReduce, we can say. Nowadays, Spark is a unified analytics engine offering batch and stream capabilities that is compatible with a polyglot approach to data analytics, offering APIs in Scala, Java, Python, and R languages. Here, what is the difference between batch and stream processing? As we have discussed in our previous slides, the batch process is nothing but the entire data is divided as multiple batches. Okay, so based on the time intervals, all these batches execute one by one with respect to time, which is nothing but batch processing. And if we compare it with the stream processing is is as the data is generated on the same time, the generated data is going to ingested into the Spark engine. That data is immediately decided, and they can analyze that data based on the some insights. Okay, some insights and some tools and technologies we can apply on the generated data. Continuous flow of data, we can get immediate insights. That is the difference between batch processing and stream processing. So Spark uses that kind of batch and stream processing with a great capability, and which is compatible with all other polyglot approaches. The word meaning polyglot is nothing but it can have multiple programming languages. We can integrate with multiple programming languages. Okay, multiple programming languages like Scala. We can say Apache Spark has developed in a Scala programming language, and Java, Python and R languages. We can integrate Apache Spark with all these programming languages, which means that polyglot approach. And we can work with the batch processing as well as stream processing. And one of the best feature of Apache Spark is nothing but unified engine, which means that we can integrate all other tech tools and technologies easily with the Apache Spark, which makes it different from all other tools and technologies for handling big data technology. Okay, then what are the benefits of Apache Spark? It is providing for big data. So the primary benefit of Apache Spark is its speed. As I have told you that Apache Spark works with a continuous flow of data. So it works faster than Hadoop. Achieved through in-memory. The best feature of, benefit of Apache is, the first one is speed, and we can say, and the second one is in-memory computations. In-memory computations, which means that everything stores in RAM. Okay, it works with a faster pace as well as it stores the data in memory, RAM. That enhances processing efficiently, which is the best combination for computing any data sets. So that is the reason we can say Apache Spark is a efficient technology. It also offers scalability by adding nodes to handle large data sets. Okay, here the word scalability means as the data grows, because the data is generating continuously, as the data grows, automatically the resources and the next nodes are going to add to the existing large data sets. So there is nothing interruption in between the data collection. Okay, it also handles the scalability. So this is also one of the benefit we can say by using Apache Spark. Spark's flexibility is evident in its support for multiple data processing tasks. So as the Spark works with a distributed manner, so here the multiple tasks are handled parallelly. Okay, here multiple data processing tasks within a single framework. So here collectively we can call it as a framework. So multiple tasks are going to perform parallelly. Its fault tolerance ensures reliable computations even if the hardware fails. So what does fault tolerance means? Fault tolerance means, okay, as here the master node always have the copy of all the data nodes data sets. Okay, so as a duplicate, it with the master node stores all the data. In case of any failure, it automatically gives the existing data or stored data to that particular failed system. So which is nothing but fault tolerance. In the situation of failure also, we may get the lost data as a recovered from master nodes. So which is nothing but fault tolerance, which is one of the main benefits of using Spark. Okay, one of the main benefits of using Spark. So here we have all the duplicate data stored at one master node. Finally, Spark's efficient processing reduces resource utilizations. Okay, because of efficient processing, we can say that resources are reduced based on the situations. Operational cost also reduces as the fast processing is happening by using Apache Spark. So operational cost also reduces, making it a cost-effective solutions for big data challenges. And also we can say that it is most cost-effective solution for handling complex big data problems. So this is all about Apache Spark. In coming sessions, we'll go deep into the Apache Spark concepts. Thank you.